Let's do some examples where we go back to finding inverse functions, but this time we find inverse functions for functions that have logarithms. So for our first example, let's do finding the inverse function for f of x equals log base 3 of x plus 7. Now remember, there were 3 steps to finding an inverse function. The first step was replace f of x with y. So we would have y equals log base 3 of x plus 7. The second step is the most important, and that is where we switch the x and the y. So that would turn into x equals log base 3 of y plus 7. And the third step is usually where most of the difficult math comes in. That's where we're going to isolate the new y. Okay, so in this case, isolating the new y would be basically converting into exponent form. So remember, when we convert a log into an exponent form, I generally like to start at the base 3. So we have 3, 2, the x is the exponent, so whatever the log is equal to, that's the exponent. So 3 to the x equals y plus 7. Oops. And then quickly solving for y, our new y, we can subtract 7 from both sides, and we have y equals 3 to the x minus 7. That would be the inverse function, 3 to the x minus 7. Okay, let's do a couple more examples. Let's find the inverse function for f of x equals 2 plus ln of x. Okay, so again, change the f of x to a y, and then that all-important step of switching the x's and the y's. So y equals 2 plus ln of x becomes x equals 2 plus ln of y. Okay, and then finally, isolating the y. So clearly subtracting 2 is a great way to start. So x minus 2 equals ln of y. And don't forget, when we go, remember we were going to convert, when we go to convert, the base on the ln, the natural logarithm, is base e. So when we're converting, we always start at the base, e to the x minus 2 equals the inside, which is y. So e to the x minus 2 equals y. Oh, y is isolated. So our inverse function for 2 plus ln of x is e to the x minus 2. Okay, let's do one last example. Let's find the inverse function for f of x equals the square root of log of 3x plus 1. Okay, first step, replace f of x with a y. So the square root of log of 3x and then plus 1. A crucial step of switching the x's and the y's, x equals the square root of log of 3y and then plus 1. And then the challenging step. So to isolate our new y, definitely going to subtract the 1 since this 1 is on the outside of the square root. So that will be x minus 1 equals the square root of log of 3y. Okay, the square root is around the logarithm. So if we want to get rid of the square root, then what we'll do is square both sides. So we have x minus 1 squared equals log of 3y. Okay, now we need to get rid of the logarithm. And remember, just like in the last example, when the base isn't written in, it's either an e or a y, or a 10, pardon me. Since it doesn't have ln, it's not the natural log, this is the common log, then it must be base 10. So while we're converting, we do 10 to the other side to the x minus 1 squared equals the inside, equals 3y. Let me write that over here. 10 to the x minus 1 all squared equals 3y. So one last time, start at the base, base to the other side equals the inside. And then one more quick step of solving for that y is to divide both sides by 3. So y is equal to 10 to the x minus 1 all squared divided by 3, or in other words, our inverse function is equal to 10 to the x minus 1 quantity squared divided by 3. Great.